Question 3. An aqueous solution of a salt is tested and the following results are obtained. The first test is adding a few drops of aqueous sodium hydroxide and then excess of it. And the second test is using aqueous ammonia, same thing. The test of using aqueous sodium hydroxide and aqueous ammonia is the test for cations. So if there were to be any N ions in the options given, we can immediately eliminate them. So let's do a quick recap for the test for cations. There are two reagents that can be added: aqueous sodium hydroxide and aqueous ammonia. For aqueous sodium hydroxide, there is either a white precipitate formed, 3 colored precipitates, or no reaction is seen. The white precipitate form includes zinc ions, aluminium ions, lead-2 ions, as well as calcium ions. The colored precipitates, there are only 3: copper 2+, rest are iron ions, iron 2 and iron 3 ions. The respective colors will be blue, dirty green, and reddish brown. When no reaction is seen, it could either be a group 1 cation or ammonium cation. For the test with aqueous ammonia, most of it is the same, except calcium 2+ ion is going to fall under the no reaction category. Copper 2+ blue will change to a deep blue solution in excess aqueous ammonia, and zinc 2+ ions is going to be the only ion that can dissolve in excess aqueous ammonia. For the test with aqueous sodium hydroxide, all the zinc, aluminium and lead 2+ ions are going to be soluble in excess aqueous sodium hydroxide. But in excess aqueous ammonia, only zinc can dissolve. For calcium, it is insoluble in excess aqueous sodium hydroxide. So for test number 1, sodium hydroxide is used and a white precipitate is formed. So we have to look under this category, and it seems that the white precipitate dissolves when we add excess sodium hydroxide. So it cannot be calcium, it could be zinc, aluminium or lead ion. So let's write down here that it could be zinc, aluminium or lead ions. The second test using aqueous ammonia forms a white precipitate again, so it could either be zinc, aluminium or lead in this case, because calcium ions will show no reaction when we test with aqueous ammonia. The white precipitate remains when there is excess aqueous ammonia. So we know that when testing with excess aqueous ammonia, only zinc can dissolve in excess, which means the other 2 ions will not dissolve and the precipitate will remain. So this shows that it can either be aluminium or lead ions. Therefore, zinc cannot be the correct answer in this case. So out of all the options given, we should be looking for either aluminium or lead 2 ions. Therefore, A is the correct answer.